So we're talking about perpendicular lines. And we've analyzed a couple of lines in class. And here we have slopes, -2, 1/2, perpendicular lines. 3/5, -5/3. We've got -1/4 and 1/4. Those are perpendicular line slopes. 8/7, -7/8. What do we notice about slopes of perpendicular lines? Yes. So one's positive, one's negative. And then that, we have a mathematical name for that. Do you guys know what that is? Reciprocal. Who said that? Brilliant. Reciprocal. So we say that slopes have negative reciprocals. Let's take this on page 22. You see where we are in the notes. If I give you an example, let's do a couple of examples here, of -7, what would be the perpendicular slope to that? It'd be 1/7. See how one's positive, one's negative, and it's the reciprocal. So it's the negative reciprocal is what we're looking at. What about 2/3? What would be its perpendicular slope? -3/2. What about 1/5? What's its perpendicular slope? -5. What about 1? What's its perpendicular slope? -1, because 1 is just 1/1. What about 0? What's the perpendicular slope?
0. Nothing. Those are my two guesses.
Nice, because 0 is a horizontal line. Vertical would be the line that's perpendicular, and vertical lines have undefined slopes. Very nice. Undefined.
On a test like 1/5, if you write it as -5/1.
Okay, so we know that slopes have negative reciprocals for perpendicular lines. We say one of two things. Either slopes are negative reciprocals, which I'm sure is what you're going to gravitate to, or the proper mathematical definition, slopes of perpendicular lines have a product of 1. Let's take an example. If I have a slope of 3/5, what would be its perpendicular slope? -5/3. And if I multiply those, what do I get? -15/15, which is -1. So you can see slopes of perpendicular lines will have a product of -1. That's one way of looking at it. Okay, any questions on that? Let's go next page. -y1. Whoopsies. Whoopsies. Here we've got line 1, line 2, and we want to find the slopes to see if these lines are perpendicular. So take a minute, find each slope, and then let's go over this. So we get that the lines are or are not. They are perpendicular. Why? The slopes are negative reciprocals. Negative reciprocals. Or you could say the slopes have a product of -1. You could say either, and that would get you the correct answer. Now moving on to the classic ACT type question. What is an equation of a line perpendicular to this line that contains this point? So what information must we extract from this equation? Just the slope. Do I need the y-intercept? Nope, I'm going to cross it out. So here the slope is 1/5. Slope is 1/5. A line perpendicular will have a slope of what? Good. -5. Because you take the negative reciprocal. And so you get a slope of -5. That's the slope we need to use. This is the point we need to use. And you can solve this one of two ways. So we can either do y = mx plus b, or we can do y minus y1 equals slope times x minus x1 and plug in x1, y1. Honors pre-calc will use point slope form a lot. I want you to get used to that. Just be familiar with it. Okay, y equals mx plus b. Plug in the y, plug in the x. I'll give you a moment to try this on your own, and then we'll go over it. So over here, we're going to be doing point slope form. And so you get y minus -4 equals the slope x minus 15. So this is y plus 4. Oops, don't need that. And we're going to distribute the -5 in. And then subtract 4. So we get y equals -5x plus 71. It's exactly what we got doing the other method. It's just usually in Algebra 1 and in Algebra 2, you will see the method y equals mx plus b. Pre-calc, you're going to be seeing that point slope form quite a bit. Any questions on this? Okay, so we got another one. Work with your group on this, and then we'll go over it when you finish. So we're going to do y minus the y coordinate, which is 7, equals the slope times x minus the x coordinate, which is 5. Now we're just simplifying this to solve for y. So the first thing you do is you distribute in. So I get y minus 7 equals 2/3 x. And then the minus, this is really 5 over 1, so I'm doing 5 times 2 over 3 times 1. And then I just add 7. And this will give you 3 2/3. Feel free to use a calculator. Back in the 80s, we did not use calculators, so we're all about making it a mixed number and then just doing it in your head. So, but you could do either. That's right. Okay, but y equals mx plus b is fine as well. Here, 2 times 5, put it over 1, multiply across 10/3. You also get it there. What questions do you have? Okay. Perpendicular, most common mistake people make is you read it too fast and you want to do parallel. So you want to extract the exact same slope. Be very careful. When it's perpendicular, stop writing on his paper. Then it is the negative reciprocal slope to this one. All right. For an extension, I want you to look at this example. So for honors, I definitely want you to be able to handle this. And I'll talk about a constraint that we'll deal with here. For regular geometry, you could try it. So, well, let's graph this guy first. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. We've got 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. We get, thanks, Felipe.
I thought we were singing.
Oh my gosh, I like you more and more.
Thank you.
So I'm going to put this, the app I'm using does not straighten this line out for me. So you just deal with this line being a little wobbly. Y equals negative 2/3 x plus 5. Now, we need 2 other lines. You guys know that the opposite side must be parallel. And does it matter where that parallel line is? Nope. But 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. 1, 2, 1, 2, 3. Come on, I was waiting. 2, 1, 2, 3. Ooh. Okay, again, does not straighten the lines. Those are parallel. Now, I know what the y-intercept was here because I was very strategic in putting it where I wanted it. Negative 2/3 x minus 2. Now, the other 2 sides are perpendicular, and this is what I was talking about as another constraint. What is the slope of a line perpendicular to these? Instead of negative 2/3, it'll be what? 3 halves. So I'm going to go 3 halves. Let's say your constraint is it must go through this point, which is 1, 2, 3, 1, 2, 3. This is one vertice of your rectangle. Let's say that that's the situation. So from here, I'm going to be going 3 halves, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, so on and so forth. There is one side of the rectangle, and that is perpendicular to the blue and the red line. But the question is, oh no, I don't know how to get the equation. But that's okay because I have a slope and I have a point. And we know how to deal with that situation when we have a slope and a point, correct? What do? We use either y equals mx plus b, or we use y minus y1, we use point slope form. So let's do y minus y1 equals slope times x minus x1. So y minus 3 equals 3 halves x minus 9 halves. And then add 3. All right, you guys do your new school ways. I'll do my old school ways. 4 times 2, so this is negative 4 and 1/2. So negative 1 and 1/2. Yeah, makes sense. There's your equation for the green line. Do you see how you do that? So if you have a constraint that does not allow you to pick a really nice, neat y-intercept, you got to go back to using y equals mx plus b or point slope form. Now, could I do the same idea with my 4th line? I certainly could. 1, 2, 3, 1, 2. This one is a nice, neat y-intercept. Perfect. Y equals 3 halves x, and this is minus 8. There you go. It's a rectangle. Opposite sides are parallel. Adjacent sides are perpendicular. I know that because of the slopes.